Right, what I want to do in this particular video is to expand on what I've said about multiplication. So previously I've pointed out that you can just multiply through top and bottom. Now the point I need to emphasize here is that although these are two separate terms, I could actually consider it to be just one separate term given by this. I mean, if I can jump ahead a bit and do a bit of algebra, if I had an algebraic expression like this, I think I'll modify that to, that's supposed to be a dot, probably, well, I'll stick it down here. Yeah, just forget about that. And that's equal to XA. I mean, this is common, that would be common to see something like this in algebra. I've mistakenly put down an X for a multiplication sign there, but in algebra, obviously, because X is so commonly used for variables or unknowns, it's advisable not to use an X in algebra. So I've used this full stop, if you like. That indicates multiplication. And using this rule on the top here, that's just become this. So that can be considered as just one term. That's two terms, but that's one term. But they are actually identical. So that's just something to learn this rule in passing. Just as I go from there to there, I can also go from there to there as appropriate. Now, if I had something like this, 2 times 3 over 9 times 7. Because I'm now considering that to be one term, I mean, what I'm saying now is fairly straightforward, but it might need a bit of thought on your part. What I'm saying is that the basic rule is that I can divide top and bottom by the same integer, if possible, and that would just produce an equivalent fraction. So what I can do is I can say, okay, there's a 3 there and a 9 there. There's a common factor there of 3. So I'll divide that through by 3 to give me 1. And I'll divide that through by 3 to give me 3. And there are no other common factors there. So I'll just now say 2 times 1 is 2, and 3 times 7 is 21. And yeah, that is automatically in its lowest terms. 2 over 21 cannot be reduced any further. Well, that's the advantage of what I've done here, is rather than say just multiply across here, multiply across the bottom, and then just reduced the answer down to its lowest terms here. What I've done is I've cancelled down first, and that as long as I carry out the full cancellation, that has automatically produced the answer in its lowest terms. So I don't need to process this any further. What you really need to understand is the legitimacy of this operation. You know, any old fraction, I can divide the top by an integer and also the bottom by the same integer, and that's an acceptable operation. So that's what I've done here. Really, this is 6 on the top here. So by dividing through by 3, I've reduced it down to 2. And really, this is 63. Dividing by this number through by 3, I've reduced it down to 21. That's what I've done, although that's not immediately obvious, because obviously there's two numbers on the top and there's 2 numbers on the bottom. But if you can think about what I've just said and realise what I've done. But the upshot of that is that if I reduce this back to its form like this, okay, 3/7, following on from what I've just said before, I can take an expression like that and reduce it or alter it to this, okay. That was the that was this rule here, and go from there to there, or I'll go from there to there, or identically using numbers. You know, you can go from there to there, or you can go from there to there. So the point of what I'm trying to say in this long-winded way is, if you can accept what I've done here, I've taken the expression and reduced it down to this form here, or altered it to this form. So basically what I can do here is I can cancel across the numbers. So I can say, okay, there's a common factor there and there, so that becomes, divide that by 3, that becomes 1. Divide that by 3, that becomes 3. Then I use the old operation of multiplying right across the top, multiplying right across the bottom. That becomes 2 times 1 is 2, 3 times 7 is 21. And that's what that's the resulting operation. So there's nothing per se, anything new in this particular video. What I'm introducing is shortcuts. Okay, the basic way right at the bottom level is, for a multiplication, you multiply right across the top and you multiply right across the bottom. That's the basic rule that will always work. It's just that you then have to look at your answer and see if you can reduce it down to its lowest terms, because in anything like this, that's the answer that we want. We just don't want any old fraction. We want the fraction in its lowest terms. So what I'm doing here is I'm introducing a shortcut such that by cancelling down, if I can, the answer that comes out is automatically the number in its lowest terms. I mean, I just need to add something on the bottom here. This is something you perhaps need to think about. You know, I don't want to labour the point, but there is a mistake which is made even by A-level students, where they come across something like this. And what some A-level students, or even A-level students, will do, will look at this and say, okay, I'll divide that by 3 to give me 1, and I'll divide that through by 3 and give me 3, and like that. But that is wrong, okay? The basic rule on fractions is that you can divide the top by a particular integer, and you can divide the bottom by the same integer, and that's perfectly okay. But that's not what I've done here. You know, that's really 6. So I divided that through by 3 to give me 2, even though I just concentrated on one of the particular numbers there. But if I do the same thing here, that is really 15. So if I was to divide that through by 3, that would give me 5. But that's not what I've got here. I've got 3 plus 6, which is 9. And the whole point here is that this is not a multiplication. I mean, this is the reason I'm a bit cagey here is that this is fairly straightforward, but it's just something you might need to think about. That is really 6. So although I've just operated on one number, I have really reduced the 6 down to 2. That is 15. But because that's an addition sign, just by operating on one of them will not change the whole thing to will not divide the whole thing. Okay, that's 15. So if I operate on just one number, that will, you know, if I divide one number by 3, that's not going to change the whole thing to 5. It's one of these points that I don't want to labour. It's something I can leave you with to think about. Look at another way. That is a common error. Well, it's quite a common error at GCSE level, and an error that you do sometimes see at A-level standard as well. So it's as well to give it extra prominence here. But yeah, anyway, that's all I need to say on this particular video. Thanks if you're still with me.